there is an object in our galaxy. Right now, not a black hole, not a supernova, something far stranger. A dead star, the size of a city, spinning 700 times per second, with a magnetic field so violent, it would unravel your DNA from the distance of the moon. In 2004, one of these objects blinked, just once, for a fraction of a second. That single blink released more energy than our sun produces in 250,000 years. We felt it from 50,000 light years away. Scientists called it a soft gamma repeater. That's the polite name. The real name is Magnetar. And there is one sitting in our galaxy right now, armed, unstable, and pointed at nothing in particular. Today, we're going inside the most dangerous object ever discovered. Every star dies. That much we know. Our sun will swell into a red giant, swallow its inner planets, and collapse into a quiet white dwarf. A cooling ember drifting through space. A slow, dignified death. Almost peaceful. But some stars don't get a peaceful death. When a star 20 times more massive than our sun runs out of fuel, it doesn't fade. It detonates. In less than a second, the entire outer shell of the star, millions of miles of plasma, gets blasted into space at 10% the speed of light. We call it a supernova. It briefly outshines entire galaxies. Every atom of iron in your blood was forged in an explosion exactly like this one. But the explosion is not the story. The story is what gets left behind. At the center of that violence, after the outer layers are gone, the core remains. And gravity, with nothing left to resist it, crushes that core with unimaginable force. Protons and electrons are squeezed together so violently, they merge into neutrons. The entire mass of a star, something that was once larger than 1,000,000 Earths, collapses into a sphere roughly 20 kilometers across. That's smaller than most cities. You could drive around it in 20 minutes. But don't let the size fool you. That object is so dense that a single teaspoon of its material would weigh 1 billion tons on Earth. It spins hundreds of times per second, a leftover from the dying star's rotation, now compressed into something almost impossibly small and fast. This is a neutron star, already one of the most extreme objects in the known universe. But occasionally, rarely, something goes wrong during the collapse. The magnetic field doesn't just amplify, it detonates. It reaches a strength so far beyond anything in our experience that physicists needed a new word for it. They called it a magnetar. And compared to what comes next, a neutron star is gentle. Let's talk about magnetic fields for a moment. The magnet on your refrigerator produces a field of about 0.01 Tesla. An MRI machine in a hospital, a device so powerful it can pull metal objects across a room, operates at around 3 Tesla. The strongest magnetic fields ever created in a laboratory, for fractions of a second, reach about 2,800 Tesla before the equipment destroys itself. A magnetar's surface field, 100 trillion Tesla. That number is so large, it stops feeling real. So let's make it real. At that field strength, the atoms themselves deform. Electrons no longer orbit nuclei in their normal spherical clouds. They get compressed into thin needles, stretched along magnetic field lines. Chemistry as we know it ceases to exist. The very structure of matter changes shape. From half the distance between Earth and the Moon, a magnetar's magnetic field would be strong enough to erase every credit card on Earth simultaneously. From that same distance, it would disrupt the iron in your blood. Your cells would tear apart at the molecular level. Not burned, not crushed, simply unmade. There is no material, no shielding, no spacecraft we could ever build that would protect you. But the field itself isn't even the most dangerous part. Magnetars don't sit still. They're unstable. The crust of a magnetar, a rigid lattice of neutrons and exotic matter, is under constant, violent stress from the magnetic field trying to reorganize itself. Occasionally, that stress becomes too much. The crust cracks. On Earth, we call crust cracking an earthquake. On a magnetar, they call it a starquake. And the energy released in a single starquake makes every nuclear weapon ever built look like a spark. In 2004, a magnetar called SGR-1806-20 had one of these moments. The crust shifted, just slightly. And what happened next was detected across the entire galaxy, including here, on Earth, 50,000 light-years away. December 27th, 2004. Astronomers weren't expecting anything unusual. SGR-1806-20 was a known magnetar, catalogued, monitored, considered quiet, far enough to be someone else's problem. At 21:30 UTC, that changed. A wave of gamma radiation struck Earth's upper atmosphere, with enough force to partially ionize the ionosphere. For 0.2 seconds, a dead star on the other side of the galaxy reached out and touched our world. The energy released, 10,000 times more than our sun will produce across its entire lifetime. If this magnetar had been just 10 light-years away, no ozone layer, no surface life, it would simply have arrived. And it's not even the closest one to Earth. The matter inside these objects exists in a state that has no name in ordinary physics. Not solid, not liquid, something beyond our vocabulary entirely. Every time one fires, it sends a message written in gamma rays from energies no human technology can approach. We are made of atoms forged in stellar explosions. We have spent our entire history completely unaware that objects like this exist. That is the magnetar. Not a villain, not a threat with intentions. Just physics, operating without mercy, at the edge of what reality permits. And somewhere out there, right now, one is building toward its next moment. We just don't know which one or when. If this is the kind of journey you want to keep taking, subscribe to StarVoyager. Every week, we go deeper into the universe than most people ever thought to look.